It is significant that we're coming together now, during this historical moment, a challenging time for art and science, a challenging time for all of us.
One of the crucial elements in this project is the opportunity for conversations across cultures and languages, how knowledge can be translated across the different disciplinary communities. So in this research project, we ask ourselves, can there be permeability between knowledge areas? And if one moves across languages, is it possible to work with diverse groups of people, even if they do not speak the same language? Thank you, Elvira, for that. One could answer with art critic Nicolas Borio's premise, the artist is cultural nomad. And art historian Lynn Gamwell argues we are concocting a new language for the incomprehensible.
Some of the challenges that excite us for a studio-based context are how to represent the unknown, or a thing that is not perceptible, to sensible knowledge. What does it mean to know things that are not physically perceivable to us through our senses?
Physicist Lisa Randall talks about the difference and the common aims between physicists. And we believe this also applies to artists. She said, you might say that we are all searching for the language of the universe. There's a quote up here from Elizabeth Groves as well. Science, like art, plunges itself into the material of the universe, though with very different aims in mind. This is not to say that art does not draw on science, or that science does not draw on art, but in drawing on the other's resources, each must transform the work of the other into its own language and its own purpose.
You know, physicists are love to play. You know, it's just we have a really big sandbox and a PhD, and we just play. You have fun. But the fact of the matter is that antimatter is an absolutely essential, everyday component of the universe. It is part and parcel of this universe. It's actually completely normal in that sense. It is absolutely necessary to make our understanding of the universe whole.
Now, how we see anti-atoms? I think it's a little bit philosophical what you mean by seeing something, observing something. So that's something artists might want to think about. But we see antimatter, we observe antimatter by letting it disappear. The way we know that antimatter existed was by artificially letting antimatter hit the matter and then observing the annihilation reactions. Then you saw that okay, antimatter had existed.
Now I can wonder, suppose I can take antimatter and smush it together with antimatter. Can I convert this into energy and vice versa? And the answer, it turns out, is yes. The reason that antimatter is so puzzling isn't that it's weird or mysterious or funny stuff. It's actually that it's not weird or mysterious enough.
As David was saying, we have in the early universe only one extra matter particle for every billion antimatter-matter pairs. So what does 1 in a billion look like? 1 in a billion, we're going to have to wait 30 years. So picture waiting all the way until 2047, and all you're doing is trying to find 1 second that's special. So that's how rare that extra matter particle was compared to all of the pairs of matter-antimatter. So antimatter comes from all around. We were saying cosmic rays will produce antimatter. About 0.02% of particles from cosmic rays will be antimatter, and in a square meter, anywhere on the Earth, at any point in time, there's approximately 1 to 100 antimatter particles being produced at any given time.
Okay, so here's how it ties in to time reversal violation. You can see it quite clearly from these equations. However, you can also see it from the picture. So this is the neutron, that's the positive charge center, and the negative charge center, and the arrow shows the direction of the spin.
And as we've learned already, positrons are just the antimatter equivalent of the electron, and we're actually able to use this antimatter for medical purposes, so we can do actual scans. So this is a cancer scan, and that's how some of the research and some of the stuff that we're doing here on antimatter is actually being used every day by patients up at UBC Hospital to diagnose and follow the progression of things like cancer. So I think that's kind of cool.